As a reminder, we are in chapter 20 and we are working on nucleophilic addition reactions, and these are reactions where we are adding something to the carbonyl group, the carbon-oxygen double bond of an aldehyde or a ketone. And so far we've looked at adding oxygen compounds to the carbonyl group, like adding an alcohol and forming an acetal. And we've also looked at nitrogen nucleophiles being added to the carbonyl compound, and that forms an imine or an enamine. So the next thing that we're going to look at is adding hydrogen nucleophiles to the carbonyl carbon. And good news, this is a reaction that you have already learned, and you're probably pretty comfortable with it. In this reaction, we are going to be converting the aldehyde or ketone to an alcohol. So we first learned about this reaction in 242 when we were learning about alcohols. For example, let's look at a generic example of this. This is with an aldehyde, but this reaction works great with both aldehydes and ketones. There are two different reagents that you can use to do this reaction. One is two-step LAH with H2O, and this gives us, when we start with an aldehyde, it gives us a primary alcohol. So this works with both aldehydes and ketones. And also, as you know, instead of using LAH, there are other reagents we can use. In your textbook, the other the other reagent that we can use is sodium borohydride, NaBH4, in water. This is not a step 1, step 2 thing, just all together. So let's draw, just as a refresher, let's draw an example of a mechanism with this. We'll use an interesting ketone. And in these reactions, regardless of whether you're using NaBH4 or LAH, the actual nucleophile is H-, hydride. And the hydride attacks the carbonyl carbon because the carbonyl carbon is partially positive. And this causes the carbon-oxygen double bond to open up. And so the first thing that we get looks like this. We've added that hydrogen. I'll go ahead and draw it into that carbon. And we've created an O- on the oxygen. And then our step 2, where we bring in water, or we could also use acid, H3O+. This is just to protonate that negatively charged oxygen. And we end up with the alcohol, and that's it.